Okay, are you ready? Are you ready to talk about gas chromatography? If so, get out your pencil and your paper because we're shortly and quickly going to turn into an art class because we're going to get ready to draw what the GC system is going to be doing for us with an overall scheme, an overall picture of what goes on inside of the GC system itself. All right, so let's first just draw the box of the GC system. And I'm going to draw this fairly large because there's going to be some details in here that we're going to have to talk about. So I'm just going to draw one really big one, and then we'll just keep coming back to it. Yeah, my lines are kind of crooked, but that's okay because you know what? You just have to tilt your head a little to the side and it looks straight. All right, so this is my GC system, and up here in the corner, I'm just going to kind of label it as my GC box. And this is where all of the magic happens. This is where the separation takes place. This is where the chemistry takes place. It all goes inside of this box. But we've got to talk about overall, what does the box do? All right. So up here at the very top, the sample is going to have to be put inside of this GC system. So in this top corner, I'm just going to draw a small little peg up here at the top. And then I'm just going to color this maybe red. And this is going to be called my injector. Right? So the purpose of the injector is to inject your samples. I told you this wasn't very hard. Kind of makes sense. Okay, so there's pieces and parts of the injector that we have to talk about. There's pieces and parts of the injector that have to be replaced, and there's some chemistry that happens in there too. So we'll pay a closer attention to the injector in upcoming videos, but for now, just know the injector injects your samples into the machine. All right, so after the injector, what happens is that your sample goes into what we call a column. And the column, if it's a capillary column, will go round and around and around and around and around, all in the inside. And that is the glass capillary column that will begin to become the tunnel that your sample will go into. And inside of this tunnel, your components will begin to separate one from another. All right? So this is my column. The column can come in different forms. The column can come in different sizes. The columns can make your components behave differently depending on what you put on the inside. So we're going to have to take a closer look at more details about the columns and about what they do and about how they operate. But the column is where your mixture begins to get separated. So the mixture separates. Okay, well, like any tunnel, there's an entry and an outlet. So if the sample comes in one end of the column, the sample has to go out the other end of the column, right? So eventually your sample will come inside and out. All right, now over on the right-hand side, I'm going to draw another peg or another box, and I'm going to color this one purple, and we're going to call this one the detector. So this is the detector of the instrument. And what the detector does is that it sees. It sees your components one by one, and it triggers a signal, and that signal goes over to the computer system. So the injector, the column, and the detector. The injector injects the samples into the machine. The column begins to separate the components one from another, and then those components individually, one at a time, goes into the detector and gets recorded. Now, there's different types of detectors. There's different ways the detectors are made, and we'll talk about those as well. However, In order to have this system to fully work and operate, what you need is something that will push the sample through. We have to push the sample through the injector. We have to push the sample through the column. And we have to push the sample into the detector in order for it to get recorded. Well, what we use is something called mobile phase. And this mobile phase is just simply a gas. That's all that it is. So typically over here to the side, we have a tank, and this tank up at the top will turn the valve on, and this tank will have a gas flow that goes into the machine. And that's the purpose of the gas in gas chromatography. The gas is used to push your sample through the machine and out the other end. If there was no gas present, you would inject your sample into the injector and it would stay there. It wouldn't want to migrate very easily through this 60 meter or 100 meter column and out the other end. It's just not going to do it. You need something there that will push the sample through the machine from beginning to end so you don't have to stay here for days on end waiting for your sample to come out. Right? So that's the mobile phase, which is really just the gas tank. That's all that it is. All right. So that typically overall is the schematic of the GC system. Now, these things can get more complicated than this, but I think at a bare bone minimum, this would do a pretty good job. If you could describe this to someone, then you've done a really good job talking about how gas chromatography works. It's a few pieces that are hooked together that needs a little bit of flow and extra help from some gas, and then this thing can detect very volatile compounds with low boiling points that have low molecular weights that could be pharmaceutical hazards or environmental hazards or health hazards, you name it, but that's the purpose of the GC, and that's how it begins to work. All right, so in the next video, what you will find out is more details about the mobile phase. Now, if you look at these guys' faces, I would probably assume that they would have that face lifting those heavy tanks the way that they are. Because if you try to pick up one of those tanks, just one of those in the lab, good luck to you. You'll need 2 or 3 guys to pick it up and be sluggish down the hallway while you carry it. But mobile phase we typically call carrier gas. And that's why you see the picture that you're seeing here on the screen. That's the carrier gas because they're carrying the gas that is used for the GC system. So the next video will focus on just the carrier gases and the options that we have at the table and why maybe one is better than the others. So come back. Don't take a break yet. I've only wasted 8 minutes of your time, so I know you've got a couple of more minutes to spare while you sit there listening to this video while you're on your cell phone texting a friend or taking a picture and putting it on Snapchat. So come back and see me.